The next topic is Archimedean property of real numbers. Archimedean property of reals. So the property which I am going to prove is if a greater than 0 and b is any real number, then there exists some natural number n such that n times a is greater than the given number b. So property tells me that if a is any real number, however small it may be, and b is any real number, however large it may be, I can always find a natural number n such that when n is multiplied with this small number, then small number can be made bigger than the given number b. So how to prove this thing? So suppose the theorem is false, then if there does not exist any such n belongs to n, then we have the set S consisting of numbers na such that n belongs to n less than b. If na is not greater than b, it means na is always less than or equal to b for all n. So it means the set is bounded above. So we know any bounded above set has a least upper bound by order completeness property of reals. By order completeness property of reals, there exists least upper bound, say u, such that n plus 1 times a is less than u for all n belongs to n. Here I have written NA. N is natural number, so n plus 1 is also a natural number, so I can replace this n by n plus 1. I can write here n plus 2, n plus 3 because all these are natural numbers. So n plus 1 times a is less than u, and u is the least upper bound of this set S. So this implies NA less than u minus a for all n belongs to n. So this step tells me that n and u minus a becomes upper bound for this set S. Why this is upper bound? Because each element of this set is less than u minus a. So therefore u minus a is upper bound, but u minus a is less than u. It means upper bound is less than least upper bound. How can this be possible? Upper bound cannot be less than least upper bound. So it means our supposition is wrong. So there is some n for which na is greater than b. So now we shall deduce some corollaries from this theorem. For any real number x, there exists a natural number n such that n is greater than x. So for every real number, I have one natural number, I have at least one natural number bigger than that real number. So this follows from that Archimedean properties. Now in previous result, assume a is equal to 1, which is greater than 0, and x is any real, then by Archimedean property, NA should be greater than B, which I have now assumed as x. So n times 1 is greater than x. So the result is proved. For any real number, I have a natural number bigger than that real number. Corollary 2. For any real number, there exist integers m and n such that m less than x less than n. So any real number lies between two integers. Now use this corollary. By corollary this, so by corollary 1, for each x belongs to R, we have a natural number n such that n is greater than x. So this part is already true from corollary 1. Now for second part, multiply this inequation by -1, we get minus n is less than minus x. Now use Archimedean's property. Archimedean's property for b equal to minus x and a equal to 1. This implies we have some k such that k is greater than minus x. So the property was n times a is greater than any real number. So a is 1. So multiply by -1 both sides, we get minus k is less than x. This implies, now assume minus k as m. Now combining these two results, 1 and 2, on combining 1 and 2, we get the desired result. The set of natural numbers is not bounded above. suppose n is bounded above by some real number x, that is each element of this set is less than x, but by Archimedean's property, Archimedean's property for a equal to 1 and b equal to x, we have some n such that n times 1 is greater than this x. So x is upper bound for the set of natural number, and Archimedean property is telling me a natural number which is bigger than the upper bound for the set of natural numbers. So this is a contradiction. So it means the set of natural number is not bounded above. For any real number x, there exists some natural number n such that n less than x less than n plus 1, or I can put here equalities. If n, this x is already a natural number, then I may take equality here. So earlier we have proved that for any real number we have two integers m and n such that x is lying between those two integers. Now I am saying that each real number lies between two consecutive natural numbers. So n and n plus 1 are consecutive natural numbers. So if x is a real number here, I can find a natural number n such that x is in between these two things, n and n plus 1. How to find such n such that x lies between two consecutive natural numbers? Proof. Consider the set S, which is the collection of all integers such that integers are less than or equal to x. So मैं ये कह रहा हूं कि x से छोटे जितने भी इंटीजर्स हैं उनका एक सेट ले लीजिए. So this set is bounded above by x. This implies by order completeness property of real numbers we have least upper bound for this set. Say m. अब देखिए कि इस सेट में हमने सेट ऑफ इंटीजर्स लिखे हैं. सेट ऑफ इंटीजर्स आर आइदर नेचुरल नंबर्स और their negatives or a zero. The least upper bound of this set will be the maximal element of this set. So this implies M belongs to S, but M plus 1 does not belong to S. कि अगर M इस सेट का मैक्सिमल है, इसका मतलब M plus 1 इस सेट के बाहर है. What this means? This implies M plus 1 will be greater than X. हमने ये assume किया हुआ है कि इसमें वो इंटीजर्स हैं जो x से लेस है. अगर कोई एलिमेंट इस सेट में नहीं है, इसका मतलब वो x से बड़ा होगा. अगर वो ये x से छोटा है तो इस सेट का एलिमेंट होना चाहिए. सो m plus 1 is bigger than x. So this implies this x is less than m plus 1, and that is m is in this set. M satisfies this equation, m less than or equal to x. So m is less than or equal to x, and m is the maximal element of this set. It means m plus 1 is not element of this set, so m plus 1 is bigger than x. So combining these results, I have obtained the desired thing, that x lies between any two consecutive natural numbers. Then we shall prove a denseness property of rational numbers as well as irrational numbers. Between any two reals there is a rational number, and between any two reals there is an irrational number also. Prove between any two real numbers there is a rational number. So if a and b are any two numbers, I can find a rational number between these two. This I want to prove. So this thing is trivial to prove if I already assume that a and b are rational numbers. If a is p1 upon q1 and b is p2 upon q2, then you add two rational numbers and divide by 2. The number will be here. So if this thing is a, this thing is b, the middle number is a plus b by 2 is a rational number if a and b are rational numbers. It means the theorem is trivially true if a and b are rational numbers. But the theorem is hard if I assume at least one of a and b is not rational numbers. Suppose here I take root 2 and here I take root 3, or if I take 1 here, root 2, root 3, and if I want to find a rational number between these two, I cannot use this trick, that is take sum and divide by 2. So 1 plus root 2 by 2 is a number between these two, but that number is not a rational number. Similarly, root 2 plus root 3 by 2 is a number between these two numbers, but that number is not a rational number. So it means now we shall have to do some work to find a rational number between any two real numbers. So now see how we find a rational number between any two reals, however close they are. Let xy be two given real numbers such that x is less than y. So I have already told you a trichotomy property of real numbers, which ensures that if we have two real numbers, then one of the three things will happen: x less than y, or x greater than y, or x is equal to y. So I assume x is less than y. This implies y minus x is greater than 0. So this we have assumed. Now use Archimedean's property by using Archimedean's property for reals a is equal to y minus x and b is equal to 1. We have na is greater than b. It means n times y minus x is greater than 1. So this implies ny minus nx is greater than 1. This implies ny is greater than 1 plus nx. So I call this equation 1. Now use our previous result where I have told you that if x is any real number, I can find two consecutive integers in which that real number lies. Now suppose this is a real number n. So by previous result we have some m lying in set of integers such that this nx lies between m and m plus 1. So m and m plus 1. I remove equality sign from here because if it is an integer then it cannot be both. It is either this or this. So I put equality sign here only. This thing as 2. Now by using these two equations we shall prove the desired result. So I remind you the desired result should be, here is my x, here is my y. I want to find a number in the form p over q between x and y. So I want to find a rational number between x and y. So that I will find by using these two results. Now if we add 1 here, what we shall get? By adding 1 in 2 and using 1, we have here add 1, we get 1 plus m will be less than or equal to add 1 nx plus 1. Now don't write this thing. Now use this thing. 1 plus nx is less than ny. So this is less than ny. Now use the step 2 again. This 1 plus m is greater than nx. So this thing is greater than nx. So now remove this part. This I don't need. So write this thing. Nx is less than 1 plus m is less than ny. Now divide by n. So we get x is less than 1 plus m by n is less than y. So I have proved which I wanted to prove, that there is a rational number between x and y. I have found a suitable m and a suitable n. तो अब ये देखिए कि ये m और n कोई आर्बिट्रेरी नंबर नहीं लगा दिए, हमने ये सूटेबली चूज किए हैं। कि जैसे पहले n चूज किया बाय यूजिंग आर्किमिडीयंस प्रॉपर्टी दैट n टाइम्स y माइनस x इज ग्रेटर देन 1, तो ये n तो वो वाला n है। और m कैसे चूज किया, m हमने चूज किया कि ये जो nx आया यहाँ पे, दिस nx लाइज बिटवीन टू कंसेक्टिव नेचुरल नंबर्स और टू कंसेक्टिव इंटीजर्स, तो वो m और m प्लस 1 से वो m चूज हुआ। सो n and m are two specific numbers which after certain manipulations gives me that 1 plus m over n lies between x and y. So this I have proved. So next I will prove between any two real numbers there is an irrational number. Between any two real numbers there is an irrational number. Proof. Again consider x, y two real numbers such that x is less than y. Use Archimedean's property with a is equal to y minus x, which should be greater than 0, and b is equal to root 2. In our earlier proof, we took b equal to 1. Here we are taking b is equal to root 2. Root 2 is not necessary. Here I want some irrational number. So I took root 2. So it can be root 3, root 5 or any irrational number. So by Archimedean's property we get there is some n such that n into y minus x is greater than root 2. So this implies ny is greater than root 2 plus nx. Or this further imply divide by n, we get y is greater than root 2 by n plus x, and this number is further greater than this number, root 2 over 2n plus x. Now let's see, here x is same as x, but this number is half of this number. It means the total thing I have made smaller than this number. And this thing is greater than x, because this is x plus something positive, this is only x, so x plus something is certainly more than x. This implies, अब इसको रिवर्स ऑर्डर में लिख लें, x is less than root 2 over 2n plus x, is less than root 2 over n plus x is less than y। अब हमने x और y के बीच एक इरेशनल नंबर फाइंड आउट करना था। अब मैं कह रहा हूं कि ये जो दो नंबर मैंने फाइंड आउट किए हैं, एटलीस्ट वन ऑफ दीज टू नंबर्स विल बी एन इरेशनल नंबर। नाउ consider the difference of these two numbers, this minus this, bigger minus smaller, root 2 by n plus x minus root 2 by 2n plus x is equal to this x will get cancelled with this x, so here we get a root 2 by 2n, and this is same thing is 1 by a root 2 times a natural number. So this is an irrational number. So this is not a rational number, means this is an irrational number. So last time I had proved that root 2 is an irrational number. If you divide an irrational number by a rational number, the number still remains irrational. Because if you take two rational numbers, their sum is a rational number, their product is a rational number, their division is a rational number, their subtraction is a rational number. So it means both of these cannot be rational numbers. This is from the difference is an irrational number. Since the difference is irrational number, from there I can guarantee that at least one of them is an irrational number. अब कुछ बच्चे ऐसा सोच लेंगे कि यहाँ पे रूट 2 बाई n लिखा है, तो ये ऑलरेडी इररेशनल नंबर पहले से ही पड़ा हुआ है, तो ये दोबारा से ऐसा करने की क्या ज़रूरत है। तो इस पूरे एक्सप्रेशन में अगर यहाँ पे रूट 2 लिखा है, उससे गारंटी नहीं हो रही है कि ये इररेशनल नंबर है या ये इररेशनल नंबर है। गारंटी क्यों नहीं हो रही? क्योंकि इस x के बारे में कुछ नहीं पता। ये n तो नेचुरल नंबर है, ये पता है। एनी इररेशनल नंबर डिवाइडेड बाय नेचुरल नंबर इज अगेन एन इररेशनल नंबर। दिस इज इररेशनल नंबर, दिस इज ट्रू, बट व्हेन वी ऐड x, I don't know the total thing will be rational or irrational. अब एक एग्जांपल से देखिए, जैसे मैं ये लिख दूं रूट 2 बाई n प्लस यहाँ पे ऐड कर लूं 1 माइनस रूट 2 बाई n. So suppose this is x. So when I add these two things, this term will get cancelled with this term, I will get 1. So 1 is a rational number. So since I don't know what the x will be, therefore I don't know the total thing is. Here also I don't know the total thing, what is the total thing. But I took their difference. Difference is irrational. So difference is irrational guarantees that at least one of these two numbers must be an irrational number. ठीक है? So between any two real numbers, there is a rational number. Between any two real numbers, there is an irrational number. Hence, between any two real numbers, there is a real number. So real numbers are dense.